No.
Okay, good afternoon, everyone. Today we are going to start chapter 2, and we hope to cover section 2.1 and 2.2 today. So we start chapter 2, which is about functions. So it's always the same concept, but we work with it a little bit more. So before we start this chapter, I would like to remind you some simple fact about solving simple inequalities. So okay. So suppose I tell you solve the following. Solve the following inequality. Means find the values of x that satisfy this inequality. So let us say very simple one. Solve x minus 4 positive. Okay, it means give me all the values of x that when I plug them here, x minus 4 will give me a positive number. So the way we solve them, okay, we say x minus 4 positive. We basically need to isolate the x as usual. So we add 4 in both sides. Okay, this will give me that x has to be bigger than 4. So the solution is all values of x such that x is larger than 4. So we're going to do two small problem along those lines. So let us say another problem number 2. Let us say I ask you to solve 2x plus 3 positive. Again, all the x's that make this expression positive. But the idea is always to isolate the x. So in this case, we have to subtract 3 from both sides. And this would give me 2x is bigger than minus 3. So take away 3 and take away 3. Now we need to isolate the x, so we divide by 2. And this will give me x larger than minus 3/2. So it means that the solution is all x's, all values of x that have the properties that x is larger than minus 3/2. So if I take x equal minus 1, I plug it in here. Minus 2 plus 3, I get a positive number. If I take x equal to 0, I get a positive number. But once I start taking something less than minus 3/2, like minus 2, I'll get minus 4 plus 3, I start getting negative number. Now, if I add equal sign here, the effect would be actually just adding equal sign across the board. So adding equal sign, that will be the effect. Now we're going to do one more along the same line. Suppose I ask you to solve the following. Minus 2x plus 3, again, positive or equal to 0. So I did a really a small change in here. And let us say we follow verbatim the approach from before. So I'm going to take away the 3. And this would give me minus 2x larger and equal to minus 3. Okay. Now I need to isolate the x. Now when I isolate the x, I have to divide by what x is multiplied by. Divide by minus 2. But then, what do we know about inequalities? So I want to divide by minus 2 to isolate my x. But what do we know about inequality? If I have an inequality and I multiply or divide by minus 2, how will this affect the inequality? Anybody? How will this affect the inequality? If I divide by minus, I have to flip the sign, and that's crucial. It means this larger or equal will have to become less or equal to minus 3 over minus 2. And that's absolutely crucial. Okay, that's absolutely crucial. And this will give me the x less or equal to minus 3 over 2 is s less or equal to 3/2. Okay, so in inequalities, solving them, especially the simple one we're working with, is actually simple. The only thing you have to pay attention to is that if we divide or multiply by a negative number, we have to flip the sign of the inequality. And I mean, let's see why. Suppose I tell you 2 is less than 3. Big deal. That's a correct statement. But if I multiply both by, let us say, minus 3, so I multiply both sides by minus 3, this is going to give me minus 6. Multiply this by minus 3, this is going to give me minus 9. And definitely this is flipping. Minus 6 is larger than minus 9. Okay, so whenever I have inequality, whether I divide or multiply by a negative number, we have to flip this. Okay, so this is a very a reminder of how to solve very simple inequalities in this problem, nothing really deep. All right, so now we're going to move to the first idea today, the notion of the domain of a function. So section 2.1, the domain of a function. We talked about that very briefly at the beginning of the semester. And let's talk a little bit about it more. First, I'll take an example like the one we did at the beginning. So suppose I tell you, let f be the function. So the scenario we did at the beginning, let f be the function that assigns to each student in this class, so you guys, to each student in MA153, 00, let us say the first name, their first name. Okay, so it means now I have a function, I have a rule that takes for input, so that's the input, the student in this class. So it takes a student in MA153 and it assigns something to them, their first name. So if I pick up a student in some of the students who put on chat, so I would write F of Matt Rosinski will be the first name, which is Matt. That's really how the function defined. Now, the domain in this particular scenario, the domain are basically all the input value, are all the thing that I assign something to. So the domain is the object that I assign something to. So in this particular scenario, what is going to be the domain? Back to you on the chat. The domain are the object that I assign something to in this scenario. What's the domain here? What are the objects that I'm assigning something to? Or basically the input. Quickly. Chat, wake up, I want chat. So what are the objects I am assigning something to? Okay, so if you didn't answer chat, it means probably you don't know the answer. So what I'm assigning something to are the student. So the domain in this scenario is really all the students in MA153. Not the name. Yeah, the name. You can say that. Yeah, not the first name. The first name is what the output is. So it means all the students in MA153. Every one of you is in the domain. So if you have a function which is given like a story problem, the domain is really embedded in the story itself. The domain are those objects that you assign something to. Now, if a function is given by a graph or a formula, which is a lot of functions are given by this. So now, if f is given by a graph, so we have a graph or a formula, and the domain is not specified like here, what will be the domain? So if f is given by a graph or a formula, then the domain will be, we have to give it a definition, the domain will be all the values of x all the values of x. So they are all the input value. All the values x for which my graph or my formula for which f of x yields a number or a value. So it looks like a bizarre definition. So if a function is given by a graph, the domain are all the values of x for which the formula yields a number. That makes sense. Or the graph will yield something. It gives me a value. So in those situations, we will not have something simple like before where it's spelled out for us. We have to find it. And that's what we're going to be working on the first part of the course. So let me start by examples. So my question is going to be all along today, find the domain of the following function. So I start with a function given, let us say, by a table. So we do it slowly. This is my input, the x's, and this is the f of x. So -1, 0, 2, 3. So these are the input values. And the f associated to x, let us say 2, 5, 6, 8. Okay. So in this particular case, what is the domain? In this particular scenario, I mean, what are the x values for which there is f of x yields a number? So what's the domain in this particular situation? Okay, question, is -1 in the domain? It means, do I have a value associated to -1? Okay, in the chat, tell me yes or no. 2, so we have a value. Is 0 in the domain? Yes or no? It means, is there an output that corresponds to 0? 5. Is 2 in the domain? Is 3 in the domain? Is 4 in the domain? Is 4 in the domain? No, because I don't have an output associated to it. So in this particular scenario, we're going to write the domain like this. We can open bracket if you want, -1. So there are just those numbers, very, very specific numbers. There are only those numbers in the domain. Now, all those values that I have in f of x for. Now, if I want to sketch this function, suppose I tell you sketch the graph of this function. So what does it mean, sketch the graph? It means I have to sketch all input, output, all input, output, all input, output. So if I want to sketch the graph, so at -1, we have a 2. So we assume this is 2. So that's my first point. At 0, I have a 5. So the graph is going to be a bunch of points because I only have the value here. And at 2, so this is my 2, it's a 6. I'm going to grab this like this. This is a 6. So at 2, my output is 6. And at 3, my output is 8, somewhere in here. So this is 3, and this is 8. So the graph here is actually nothing more than bunch of points. Those are the point, and -1. Okay. So very easy to read. It's really easy in this scenario just to read the domain. Okay, now suppose my function is, so here I gave you the table. Example number 2, we're going to take a function. I'm going to give you a graph. So more examples. Actually, the whole lecture will be example for you to understand. So suppose I graph the function this time. Okay, instead of giving you, I graph the function. And suppose this is -1. And let us say this is 5. And I'm going to start right here. I want my function to go up, and then my function to go up here. So this is my function. So the graph here is, the function is given totally by a graph. So the question is, what's the domain of this function? Okay, so the domain are all the x values. So the domain are all the x values such that f of x yield a number. In this particular case, I am putting a dot on purpose to tell you that that's where the graph is. So if I ask you what is f of 6, you don't know because I didn't give you anything for 6. What is f at 5.1? You don't know because I didn't give you any output for 1. So the domain in this situation are all the x value. They are the x value such that there is enough of x. So everything between 1 and 5 in this is in the domain. So in this particular function, the domain are all the x values, all the values of x, such that have the following properties. My x has to be between 1 and 5. So if you have a graph, you just look at it and said, okay, which input yields an output? Only between -1 and 5, that's what they yield in output. Another graphical example. Suppose, and this is a scenario that you will be encountering a little bit more. Sometimes a graph looks like this. So this is a -1 and this is a 5, okay? And I'm gonna almost give you the same graph as before, but I'm gonna change tiny bit here. And I'm gonna have an open circle in here. What does open circle or versus closed circle? What's the difference? If I have an open circle, it means the value at 5 does not exist. So it means we don't have an output at 5. If I have a closed circle, it means the output at 5 is wherever this value is. So if this value, for example, is 5 and -2, this tells you at 5, the function takes the value -2. If I open, exactly, Alex, if I open, it means there is no output at 5. And this will change, of course, the domain. It means, so what's my domain here? -1 will be inside the domain. 5 will not be inside the domain. So I'm opening it to exactly express the idea that it's not in the domain. So my domain here will be, as Alex said, all values of x such that x, 1, -1, oh, sorry, this should be -1, my apology. -1 has to be included because at -1 I have a value, but 5 is not included. So I have to have strictly less than 5. So the domain are exactly which input will give me outputs. Are all the x values. Now, if a function looks like this, okay, I just don't give you anything like that. What is the domain in this function? So I'm not putting, it seems to me, any restriction. What's the domain? So this keeps going forever in both directions. The domain in this case is basically all values of x. So we should not be afraid that sometimes everything inside the domain, because there is an output regardless what the input is. I wouldn't say infinity because it's all values of x. All values of x make a lot of sense to me and make sense to you as well. Okay. So if we have a graph, as you realize, basically you just look at the graph and you answer the questions. So part 2 is, what if you have a formula? So the rule is a formula. How can we actually work with the domain? So let us look at this picture right now. So the domain is always all the x's such that f of x yields a number. And that's really crucial. It means f of x should make sense to us. So let us take 3 more examples where the output is given by a formula, not a graph. So suppose f of x equal, so this is the input, and x take a number x, and it associates to it, let us say, x minus 4. Okay, so that's the rule. So the input is x, that's the input. F takes the input to 1 over x minus 4. Okay, I'm looking at the domain. It means I'm looking at the following. Which x's I'm allowed to put in here that will yield a number. So the output is a number. So let us play a little bit a game here so you understand fully the picture. Can I take 0 for x? Means if I put in 0 for x, well, f of 0 makes sense. Okay, if I put 0, I will have 0 minus 4. This is minus 1 over 4. So it yields an output. Minus 1 over 4 is a number. Okay, if I put, let us say, a 1, there is no issue. I put a 1 in here. This will give me 1 minus 4, would give me minus 1 over 3. That's absolutely yields a number. So the question, is there something I can put here so that the output is not really a number? That's really what the domain. What number I should avoid here? What number I should avoid here? Now, what if I put f of 4? Exactly. What will happen here? That's a 4 minus 4. 1 over 0, and that's really not a number. It's not defined. So the domain is all the axes. All the axes such that when I compute their f of x, I get a number. So here I start going through a list and I ask, okay, which number may give me problem? At 4, it gives me problem because I have 1 over 0. So what is the domain in here? And is there any other number that gives me problem? So what gives me problem? What gives me problem is all the x's that makes the denominator 0, because 1 over 0 is not defined. So the x that I'm not allowed to put in here is the x that makes x minus 4 to be 0. Those I'm not allowed to put them because they give me problem. So how are we going to find the domain? We're not going to guess all the time. We're going to really think, do it algebraically and make sure that our algebra makes sense. So what is the domain in this here? Okay. So all values of x, everything, all values of x for which the denominator is different from 0. Does this make sense? Every x that stops the denominator from being 0 is acceptable. But if the denominator is not 0, I'm safe. 1 over non-zero number, I'm safe. Now, how can I find all the x's? So to find x minus 4, so to find the values of x such that x minus 4 different from 0, we ask ourselves, okay, we ask ourselves the following question. When is x minus 4 equal to 0? Okay, so x minus 4 equal to 0, it means x equal to 4. So the domain will be all values of x such that x is different from 4. Okay, all right, so I want to find all the x's that make x minus 4 not 0 because I want to avoid every 0 in the denominator. The easy way to find them, I ask myself, okay, which one make the denominator 0? So I set my denominator equal to 0. I said this occurs when x equal to 4. That's the value I need to remove it from the domain. Everything else will be within the domain. Any other value except 4 is acceptable because it's going to yield a number for us. Okay, all right, let's take, so one problem when I have a function given by a formula, every time I have a denominator, I have to think a little bit. The function doesn't make sense for the x's in the denominator that make the denominator 0, so I have to remove them. Okay, so I look for all those that makes this 0. Okay, let's take other examples, of course. Suppose I take f of x to be equal to the following. And my question is find the domain. Let me take f x equal 1 over 2x plus 1. Okay, I'll give you all of you like 2 minutes to think through that and tell me what's the domain. Which x's are allowable? So think a little bit about it. Tell me which x we can have here and which we can't have. Okay, all the x's that don't equal minus a half. Do we agree with Kaylee? Yes. Which axis will give me a problem? Every x that makes this 0 is problematic. That's the axis. So the domain is the domain. Find the domain. So what we need is all the values of x such that this is not 0. That's really what we want. That's what we do. But now how can I find those? Okay, to find those, ask myself, when this is equal to 0? To x equal minus 1. It means x equal minus a half. So what makes this expression 0 is minus a half. So now I rewrite my domain more properly. All x's such that x is different than minus a half. Because if I put minus a half for x, 2 times minus a half, this is a minus 1, plus 1, 0. This creates a 1 over 0 scenario, which is really problematic. So whenever I have a denominator, I need a domain, I ask myself, what are the x's that makes this 0? Once I found them, I have to remove them, and everything else will be acceptable in the domain. All right. More examples, of course. Suppose I give you f of x to be simple, 1 plus x squared. What's the domain? Back to you. It means which x are allowable. Is there any value of x that give us headaches or is problematic? What can you say? No, this function, Alex. The one that you see, 1 plus x squared. Is there any values of x that give us an issue? No. If I take x to be 1, okay, 1 plus 1 squared. If I take x to be 0, 1 plus 0. If I take x to be a million, 1 plus a million squared. X to be negative 1, 1 plus negative 1 squared, which is 1 plus 1. So any x I can put it in here, I don't really have an issue. F of x will yield a number. So if I take f of minus 1, f of minus 2, will this yield a number? Yeah, because this is 1 plus minus 2 squared. It means 1 plus minus 2 squared, it's a 4. This is 5. No issue. So the domain here is all real numbers. Everything. There is no restriction. Okay, so not because we saw restriction, it means there will be issue all the time. Sometimes there are no issues whatsoever. It means any x I put here will yield an output. Any x will yield a number. So the domain here, all real numbers. So we should not be afraid of this scenario as well. So sometimes we have to exclude things, but sometimes we don't because there is no issue with the problem. I can plug in any x in here and I am all right. Now, two more example given by a function. All right, so suppose now I have the following. All right, and don't confuse x squared with something else. Don't confuse x squared. How do you know when the domain is all real number versus all? Oh, it's the same thing. Okay. So I can say all real number or all values of x. Okay, so I mean exactly the same thing. Okay, so how do I then? So when I say all values of x, it means I mean all real number. Okay, so it's exactly the same thing. I'm not changing the scenario. Okay. How do I know what? Sage, just in mute and ask me your question because I don't think I'm following here. How do I know that it's all values of x?
Yeah.
Usually I look at the function and ask myself, is there a problem here? Is there an input that gives me a problem?
Yeah, I was just a little confused because I couldn't tell. Like I know the difference between all the real numbers and all values of x. I mean, it's the same thing, but I'm just confused because I wouldn't be able to look at that problem and know that.
Okay. Usually, when a function is given by a formula, we have issue in this following scenario. Whenever I have a denominator, I have an issue. Why? Because the denominator can have zeros, can be 0. And those have to be removed. Okay, that's one scenario. Now, another scenario, which the one I'm going to talk about it now, which is the scenario when I have a square root. And now we're going to talk about that. In here, the idea is that, can you think of a value of x? When you plug it here, you don't have a number. You don't have an output. That's really what we're asking ourselves. Is there a value of x that I can plug it here? So what I'm doing here is I'm taking 1 plus the number square. That's my rule. And the question is, can I put any number and still have an output here? That's really what the domain is. If I put 5, yes, 1 plus 5 squared. If I put -2, yes, 1 plus -2 squared. There is no value of x that when I put it in here, I have an issue. I always have a number. Versus the previous problem. When I put f of x equal x minus 4, I said, can I put every x in here? No. Impossible, because if I put 4, I will have 1 over 4 minus 4, which is not a number. This one has to be removed. Okay? All right, so now we're going to take the following problem. F of x equal the square root of x minus 4. Okay? And you're going to find the domain. So this one, we're going to work a little bit slower with it and ask myself which input will yield a number and which one don't yield a number. Okay, so let us play the game. So this is my function. You give it an input x, something, x, and it takes it to x minus 4. All right, and now let me ask you some questions. Suppose I take x to be 6. Okay. Does f yields a number when I input 6? I'm just picking numbers from top of my head. Okay. Will it yield a number? What is f of 6? It's the 6 minus 4. That's the square root of 2. That's a number, which is 1.414. So I don't have an issue. Okay, if I plug in a 5, would I get a number? All right, 5 minus 4. Square root of 1, which is 1, because 1 squared is 1. Okay. Now, what I'm after is that can I input every number? And this one we're doing, as I said, the long way, and then we learn the fastest way. Okay, suppose I input 4. What do I get? What do I get? 4 minus 4, the square root of 0, it's 0, because so there is no issue. All right, let me go a little bit. Can I don't know, can I input 4.1? Is there any issue with 4.1? So it's 4.1 minus 4. That's the square root of 0.1. Okay, I don't know what it is, but the calculator can give me what's the square root. What's the number when you square it, you get 0.1. Now suppose I take f of 3. Okay, what does it input? 3 minus 4, which is the square root of minus 1. Now the question is this a number, a real number? Yes or no? No, no, because nothing squared give you minus 1. Nothing squared give you minus 1. Anything you square it, you're going to get a positive 1. Sorry, you get a positive number. So this one, now I'm starting to have issues. Now I'm starting to see that there are values of x. When I put here, they don't yield a number. So those values are the problem values. What if I take, 3.9? Will this yield a number? Yes or no? Yes or no? No, because if I plug it in here, minus 4. Now, this is minus 0.1. No way, this doesn't yield a number. So what really I'm looking for are all the x's that when I plug them in here, yield a number. So now, of course, I cannot go on forever. That's absolute the question. So the question is, what is the issue here? Which axis I will be allowed to put in here, which axis I'm allowed to put in here, so that this will yield a number. When will this yield a number? This will yield a number as long as the x I input give me positive number under here or equal to 0. As long as this is positive, I have a square root. I cannot have a negative number under the square root. As long as this is a positive, I have a number. The minute, no, not all positive numbers. Keep thinking. No, that's not correct. Every time I pick something that cause the term under the square root to be negative, I'm done. This has to be taken away from the domain. So 3 is not in the domain because it yields, the square root of it yields a negative number. 3.9 is not, yes, now we're fine. 3.9 is not in the domain because plugging it in is going to spit out the square root of a negative number. So what's in the domain? Everything that makes this here positive will be in the domain. Every x for which x minus 4 is positive will be the domain. Every x where x minus 4 is negative will be out. So what is the domain in here? The domain is all values of x such that, with the following property, all values of x such that the following, I write this in usually in red, such that the term under the square root is positive. Okay, every x that make x minus 4 positive. So in other words, so I wrote this in red for the first time, so you know what I'm looking for. It means all values of x such that x minus 4 positive, or equal to 0, because 0 is accepted if the square root of 0 is 0. So now I have a simple inequality that I need to solve. So I need to solve x minus 4 positive. Solve this. So we just started the lecture by solving. So we add 4. It means x bigger or equal to 4. So now the domain is clear. The domain, all values of x such that x larger or equal to 4. And that's really my number. They are those that you can, but if it's not x minus 4, it's a little bit more complicated, then you have to do the work. Okay, so this was a very simple problem to get the idea across. If it's a tiny bit complicated, you still have to solve the inequalities. All right, so what is the domain? Basic is the same idea, which x I can put to spit out a real number. And whenever I have a square root, this has to be positive. Those are the x's that will spit out a positive number. Now, how would this affect the graph? So if I am going to sketch the graph of this function, how the graph would look like? So suppose I'm sketching the graph. So this is my function f of x equal x minus 4. Okay, and I want to sketch the graph. So, the square root. All right, at x equal to 4, so let me take some point. F of 4 is 0. So at 4, the output is 0. Now, for x less than 4, everything here is not in the domain. Means there is no graph in here. So when you graph it, there is nothing in here. The graph is going to be for x bigger or equal to 4. So now if I start plugging in values, so f of 4, if I plug in 5, I get square root of 1. So that's going to be like this. 6. So if you keep plugging point, you're going to have a graph like that. And the graph will show you that the output only happens when x bigger than 4. There is nothing here, but this is not in the domain. Right? So let's do again problems along those lines. Okay. So now I'll give you 2 minutes to, and this one just to do it algebraically. Actually, I will do 2. So suppose I have the following function, find the domain. Suppose I put f of x equal the square root of, actually let me put positive for now, and then I put negative, 2x plus 3. And no, you don't have to shade. No, I'm shading it because I'm telling you what happened. You don't do anything here. So when you graph it, the graph is gonna look, you start at 4, that's the graph, period. You don't shade anything, that's the graph. Okay? So suppose I have this function and my question is find the domain. Okay. And before you do the math, let me ask you questions. Is 0 in the domain? I want yes or no. And how do we know? Is 0 in the domain? Means if I plug in 0 for x, will this yield a number? Yeah, 2 times 0 plus 3. Yeah, that's 0 is in the domain. Is minus 2 in the domain? Is minus 2 in the domain? Means if I plug in minus 2 for x, okay, minus, I'll have minus 4, absolutely not in the domain. Is minus 1 in the domain? No, yes, no, what? Yes, okay. Let me plug in minus 1. So if we're hesitating, I do it. If I plug in minus 1, I will get minus 2 plus 3. That's the square root of 1, absolutely in the domain. That's a real number. Now, of course, we cannot go on forever. Now, I want you to find the domain. You have 2 minutes to do it. And then I'll take it from there. Don't guess it. Try to imitate what I did in the previous problem. What is it you want to be positive? What's causing the problem? Okay, anybody ready? All values of x greater than or equal. Okay, I have an answer. Let me see if I can make sense of it. So what's the condition here to find the domain? Because I have a square root, I have a problem. The problem is I want to avoid, the only x's I'm going to allow here are the x's that make 2x plus 3 positive. That's our restriction. So the domain, so to find it, we need to find, that's what we need to find. All the x's, all the values of x, such that 2x plus 3 positive or equal to 0. That's really what I need to do. Okay, because everything that makes this under the term under the square root, to be very careful, that's the term under the square root that I want to be positive. Now we solve for it. So I put, okay, I need 2x plus 3 positive. It means 2x, I have to take away the 3. It means 2x greater or equal to minus 3 half. Minus 3 half. Okay, so what's going to be the domain? The domain will be all x's that have the properties such that x, my apology, x larger or equal to minus 3 half. That's the domain. Okay, now one of your classmates told me x larger or equal to minus 1. That's not right, because x can take minus 3 half. If I plug in minus 3 half, here I will get 2 times minus 3 half, which is minus 3 plus 3, I have 0. So minus 3 half is in the domain, or minus 1.5 is in the domain. minus 1.4 is in the domain. So if you put this is absolutely not acceptable because you are removing part of the domain when you put x larger or equal to minus 1. Okay. Now, if we graph this function, that's what's going to happen in here. This is minus 3/2. The graph is going to be right there. So that will be the domain. So there will be no output here because the function is defined. The output will be right there. Now, what if I play a little bit with the same function and I give you the following? Let's make it a little bit more, not much complicated. And I divide by that. How will this affect the picture? So I want the axis that makes this expression making sense. How will this affect the picture? But we have two issues here. We have something under the square root. This has to be positive. Only the axes that make this positive will be acceptable. And what else we need? What else do we need? So we need this to be positive. So we need to find all axes such that everything under the square root has to be positive. But what's the difference between this problem and that problem? What's going to be the difference? Can anybody figure out the difference? So the first one was, I'll write it in front of us here. The first one was the square root of 2x plus 3. This one is 1 over. So what's going to be the difference? No. What do you mean by the sign, Kayla? What's going to be the difference? When I took this function, I said I want 2x plus 3 positive or equal to 0. And 0 here is allowed because the square root of 0 is 0. What's happening in here? Can I allow this expression to take the 0 value? Can I allow this to take the 0 value? If I allow this to take 0 value, I will have 1 over the square root of 0. It's exact. So what I want is 2x plus 3 to be strictly positive. Strictly positive because I cannot allow this to be 0. So now the restriction in the previous case, because this expression was not in the numerator, could be 0. Here I have to remove the condition. I cannot allow this to be 0. So now we solve for it. And x is larger than minus 3/2. So the difference now is that minus 3/2 will not be allowed. So the domain is going to be all values of x such that x strictly greater than minus 3/2. So we will not be allowed to take minus 3/2 into the picture. So two places where if a function is given by a formula, there are, at least for us right now, two scenarios where we can have problems. Every time my function involves a denominator, I have to be careful and remove the x's that cause the denominator to be 0. Whenever my expression involves a square root, I have to be also very careful. I want to make sure that I only allow the x's that make what's under the square root to be positive. So these are about the only scenario we are dealing with now, because these are the only type of function we can actually work with, right? So before we hit the range, I will give you the chance to do one more by yourself, and then I will do the range. So I'm gonna mix match. Suppose I give you this function. I want you to be careful, and I ask you to find the domain. So it's a little bit harder, but not hard too hard. I want you to analyze it very, very carefully. And ask yourself which axis I should avoid here. Okay, who would like to talk a little bit? X cannot be 0. Do you agree with Kirsten? X has to be non-zero. Do you agree with your classmate? Yes or no? Yes, because 0, we cannot have that in the denominator. So we have two issues here. We have a denominator that we have to remove every value of x that makes the denominator 0. So that's condition. Then what else? I have a square root. I also want everything under the square root to be positive or equal to 0. So here I need two things. I want x to be not 0, and I want what's under the square root to be positive. So x plus 4, it means I want x to be minus 4, greater or equal to minus 4, and x different from 0. So minus 3 will do. Square root of minus 3 plus 4 is square root of 1 over minus 3, it will do. Minus 2 will do. Minus 1.5 will do. Minus 1.6 will do. However, minus 5 will not do because it makes this negative. Minus 4.1 will not do, let's make this negative. 0, of course, will not make 2 because it makes the denominator 0. So there are here two issues. So the domain here will be all values of x, such that two things are x and x different from 0. That will be really two issues. So the graph will be actually kind of a problematic graph that eventually one day you guys will learn how to do that. First, x should be minus 4, and at x equal to 0, there is no output. So the graph is going to avoid touching this line because for 0, there is no output. So the graph is going to look kind of interesting, something like that. So it's a little kind of weird, something like this. It will avoid this line because there is no output at 0, and it avoid everything less than minus 4 because there is no output there either. Right? So the domain, it makes sense because whenever you have a formula, you're going to ask yourself, what are the input I am allowed to put? Can I put anything? And the question, not all the time you can put anything. Now, part 2 is the range. So what's the range? The range. All right, function, as I said, it has an input. So you give it something. And this function will actually spit out something. So there is an output. The range are basically all the output values, all the f of x. So what's the range? Let f of x be a function. So the range of f are all, if you want, the output values. Means all the f of x. So in other words, that's the picture for a function. You give it something, and this function gives you an output, whatever. The domain are all the x values. that you can associate a y values for them. The range are all those y values you get. This is the range. So let us start with a fairly simple question. So suppose I have a function f, and like 1, 2, 3, 4, and this is what f assigns to each one of them. To 1, let us say it assigns -2. To 2, it assigns 3. It assigns 4, and it assigns 6. Okay, so it takes 1 to -2, 2 to 3, 3 to 4, and 4 to 6. That's really what my function is. The domain are all those x values. So the domain here are all the x values. So the domain is 1, 2, 3, 4. The range is are all those y values. That means are all those values here that are coming from somewhere. So 1 is sent to -2, 2 is sent to -3. So all those values that something is assigned, that we assign something to. So the range here are the -2, the 3, the 4, and the 6. So they are all the output values. So a function has the input and the output. The domain are all the x values that such that f of x is a real number. The range are all the y values that we get once we change our x value. Okay. Now, finding the range is hard. And the only way we're going to find the range in this class is actually by giving to the graph of the function, as we will see in a second. And we're going to read the range from the graph. So I'm going to sketch a graph, and you guys will have to read it from it. So let me sketch 2 graphs, and we're going to read the range simply from the graphs, all those output values. So let me see the following example. I'm going to do that. Okay, so we're going to think of the range. So I'm going to take -1, and let me see, this is 5. And I'm going to graph my function like this. This is going to go up, and my function is going to go down. That's my function. And I need to give you numbers. So I'm going to put a 1, a 2, a 3, a 4, 5, and it's a -1, -2, and this point is -3. So this point right here is 5, -3, just to be very clear. And so this is the graph of my function. And now the question is, first, what's the domain? And second, it's going to be, what's the range? So first, what's the domain? The domain are all those input, all the x values, for which there is a y value associated to them. So the domain here, this is the domain right there. That's my domain. So the domain is all the x values such that x is between -1 and 5. Okay, now what's the range of this function? The range are all the output values. What do I mean by all the output values? It means all the y values that come, that you can give me the x that correspond to them. That's what the range is. All the y value that have an x such that it's associated to this y value. So let us take, for example, -4 here. And my question is -4 in the range? What do I mean by that? It means, can you really find an x such that f of x is -4? That's what it means in the range. So is -4 in the range? It means, can you give me an input, a value of x such that f of x is -4? Of course not. So -4 is not in the range. So the range are all those y values that they are coming from a certain x, and x is associated to it. So now which are the y values which are in the range? It means is -3 in the range? It means can you give me an x value whose y value is -3? That's what it means in the range. So everybody tells me yes, because according to my graph, 5 goes to -3. So -3 is in the range. Is -1 in the range? Yeah. Can you give me an x that goes to -1? Yes, you can. Is 4 in the range? Yeah. There are two x values that come into the 4. So what is the range in this particular picture? So the range are the y value. So what's the range? What are all the y values that you can find in x that's assigned to them? So we go through the list. -3 is in the range. What about -3.5? Is it in the range? It means, can you find an x value? No? Okay, Katie told me -3.5 is not in the range. She's absolutely correct. That's -3.5. There is nothing that gives me -3.5. So what is the range? What is the range? The range is going to be all the y values such that what? Where should the y be? The y should be between -3 and what? All the way up to here. All the way up to here. That's the range. So from -3 all the way up to 5. So the range is this here. It's right there. It's on the y-axis. All the y value that could be obtained by an x value. So this is the range. Okay. So it's all the y value that could be obtained by an x value. So let us take another example. Again, a graphical example. Let us say I'm going to replicate. So the range is just lowest to highest y value in a way, but I would not think about it this way. I think about it all the y values that you can find an x value assigned to them. Okay, because I can create a symbol where there is no highest value. So example number 2. Let us say, I'm going to imitate the same thing, basically, with a slight variation like I did for the domain. I'm going to start here, and I'm going to move it all the way up. And I want this 5. So, and then I can go like that. I'm going to open my circle, and I'm going to let this to be 5 here. And let's see, this is -3 in a way. Okay, so I kind of played a little bit of a simple game just to emphasize the idea of an open circle in here. So what is my domain? So we did that at the beginning. If it's an open circle, it means at 5, I'm not giving you an output. So the domain are all values of x that has the property x between -1 and 5. Okay, so that's my domain. That's the domain. 5 not included. Okay, 5 is not included. 5 is not included because I'm opening it. I'm not giving you an output at 5. If I close the hole, it means at 5, the output is -3. Opening the hole, because we're going to get to that in the following section. I need those. For opening the hole, it means I am not giving you an output at 5. I am not giving you an output at 5. It means 5 is not in the domain. So it's crucial here. So it's not less or equal, it's strictly less. Now, what's the range in here? Okay. So they are all the y values that have an x assigned to them. So what is going to be the range? Right. Of course, everything up to here. But what's going to change in this scenario? -3 will not be in the range because there is nothing really that being assigned to -3. Because I opened my hole, 5 is not assigned to -3. So there is nothing assigned to -3. If I go back here, no x is assigned to -3. But however, if I move tiny bit away, I take here, this is in the range because there is something assigned to it. So the only change here, it's going to be all y's, such that a y is strictly. So 3 -3 is not, so it's strictly between -3, but it's less or equal to 5. So that's really what the range here. I exclude 3 -3 because there is no x that's giving me a -3. Right. Now let's see if I give you the following function. Okay, so as I said, the range, we're going to really find it graphically most of the time. It means we sketch somehow the graph and we look at it because in general, it's kind of hard. So suppose now I give you the following function that you're going to encounter by the end of the semester. So the function look like this. It's like, and then it goes all the way up. Okay, so I'm not putting restriction on my domain at all. So here I want for every input to have an output. And the question, what's the domain? And what's the range? Okay, back to you. So let us understand the graph. The graph keep going. It never touches it. It never touched this line. Just keep going. And then, okay. So what is the domain? According to my picture, what's the domain? And this keep going forever. I'm not stopping. I'm not stopping anything. All real numbers, everything, because I'm not stopping. All real numbers, or you can say all values of x. No, nothing, stop, anything. Now, what is the range? Okay, now what's the range? Means what are all the y values that I can find that are coming from an x, from an input? All number greater than 0, do you agree with Kaylee? Of course, every negative number is not in the range. If I take any number here, there is no x that's really coming from it. So these are out of the picture. Now, every positive number, okay, that's in the range, is coming from somewhere. Even if the number is here, it's coming from somewhere. The only thing not in the range is 0. Because if I look at the graph, there is nothing that's giving me an output of 0 because the graph is not actually crossing the x-axis. So it's never going like this. It's just going almost parallel to it, very close to it, but it keeps moving. It never crosses it. So 0 is not in the range, but everything else positive is in the range. So the range is going to be all values of y such that have the following properties: strictly positive. So y has to be strictly positive. It cannot be equal to 0. The only way y could be equal to 0 if, I don't know, how can 0 be in the range? How can 0 be in the range? For 0 to be in the range, it means you have to be able to give me an x value whose output is 0. The only way this can happen, for an x value to be equal to 0, the graph has to touch that and take off. Then 0 will be in the range. In this scenario, my graph is never touching the x-axis. So there is 0 is not an output value. So the output value is everything positive, but 0 is not because the graph is not really touching this. at all. It keeps moving very close to it, but never touches it. That's why all the y values were strictly positive. 0 is not in the range because there is no input that gives me an output of 0. Okay? So we saw two ideas, domain and range. The domain are all those inputs such that f of x makes sense. The range are all the y value that comes from a input value. So all the y that if I tell you y is in the range, it means there is an x somewhere, so that f of x is equal to y. So this is what we call them all the output values. Right? So I'll finish this with asking you to do the following, just for the fun of it. Actually, your Moodle homework has a lot of those problems. Sketch the graph of a function. Sketch the graph of a function f. And I've done a lot like that, such that the domain is all x's, values of x, such that, let us say, x between, I don't know, -2 and 5. And the range, all the values of y, such that y between 0 and 3. 0 included, 3 included. Okay? So, I want you to spend, we still have a few minutes. I want each one of you just to give it your best shot. I'm giving you the domain, I'm giving you the range, and I'm telling you, okay, sketch a function that have this property. Okay, I give you 2 minutes. Unfortunately, I cannot see what you're doing, but I have to do the best I can with that. Okay. So let me ask you questions. If you want the domain to be between -2 and 5, what this will give you for a hint immediately? So those values are on the horizontal or vertical axes at least. Those values, they are the inputs, so those have to be right here. This is the -2, and this is the 5. So that's really my domain. Okay. Now, my range, it means I want all the output to be between 0 and 3. So I'm just really setting up now that I'm going to graph. So I want them between 0 and 3. So this is my range. So that's my range. And that's really my domain. Now I have to sketch a function, that satisfies this condition. Anybody have any idea that can explain it to us, how they sketched it? And mute and just talk. Any of you? So draw anything, as long as this is your domain and this is the range. And we have to be very careful. Okay, it would just go up toward y-axis of 3. It would just go up toward y-axis of 3 toward 5. Oh boy, I can't follow, Zach. Can you say it in words? Tell me what to do. Okay, he's drawing a line. So if I understand, he's drawing a line. He's starting here. Correct me if I am wrong. And at 5, he's going like that. And he said, okay, that's a possibility. Does this make sense? Is it the only way, or you can graph a lot of them? Who have another idea that can express it the same way Zach did? So I need other idea. I don't want it to be increasing. So who can play a little bit? So this is my domain. And this is my range. You can graph it a little bit differently. So that's a possibility. Is it the only one? Definitely not. Who can give me another scenario? All right. Suppose I start here, somewhere in the middle, just for the sake of it. What can I do to make sure I cover? Suppose I start like that. What can I do to cover everything? What do you want me to do after that? So there are a lot of possibilities. It could be a line. That's a very good idea. Can you do like a roller coaster starting at -2 and ending at 5? I can do that. I can do anything. I can go up. I can go down. I can go down to 5. That's a function. That's the domain, but I have to hit 5 because I want 0 in it. And I have to hit 3 because I want 0 in it. And I have to hit everything between 0 and 3 because I want, that's my range. That's another really possible. So there are a lot of ways you can sketch this graph. All right, that's it for today. For Tuesday, for Thursday, of course, you will have a quiz. But I will only give you practice problems because the Moodle problem, I'm going to give you Moodle, but it's going to take a week. So at least for this Thursday, I want you to do practice problem because your quiz will be based on them. So the practice problem from the book. And then the Moodle homework will be due because we have a fall break next week. So the Moodle homework I will give you will be due on Thursday, Thursday after the break, which is whatever the idea is. So it's going to be Thursday after the break. I will make that clear on Brightspace. Okay, so for this coming Thursday, for your quiz as preparation, you do all the practice problems. That's what I want you to do for this coming Thursday. Okay, and then the Moodle will be due a Thursday after the break because I will have more stuff in Moodle than what I did today, domain and range. Any questions before we let go? Any questions? Okay, so enjoy the homework and I'll see you on Thursday. Bye-bye, guys.